I came from Trax Technology. לתוך המיקרופון. Okay. So my name is Yair. Thank you for coming. Today I want to talk about computer vision. It's something that I'm doing for the last 10 years or so. And as I said earlier, I work in Trax Technology. I'm the head of the research there. The thing that I want to talk with you today, it's, as many things in Israel, divided to three parts. Firstly, I would like to talk about what is computer vision, and I hope that by the end of the talk you understand what is computer vision, or at least the spirit of computer vision. Secondly, I want that we all going to do together an example of one algorithm in computer vision, face detection, and you can do it after that in your home. And lastly, I would like to show you what Trax Technology is doing and why computer vision is so important to Trax Technology. So what is computer vision? So a good, explanation or definition for computer vision might be teaching the computer to see. Or alternatively, you can think of it as anything that you can do with image or video or data that you collect from a real world. Israel is a CV, computer vision, CV nation. There's many companies in Israel that doing computer vision and a lot of application, software, product using computer vision. You all know Kinect. You all know Kinect. It's a company from Israel. It's detect the skeleton of a person, and you can control the game console with that. Mobile from Jerusalem. Sorry. So Mobile from Jerusalem, they took a camera, they took a computer to put it inside the car. The computer understands the scene of the car, the scene of the driver. And for example, here, he can detect an emergency and stop the car to avoid hitting a person in the street. It's all based on computer vision. Face.com, that sold to Facebook, can recognize any person on the web. Obama, Leonardo, very cool stuff. There's several companies in Israel that are doing a hand gesture. The idea is to control a device only by hand. No camera, no keyboard, nothing at all. Several companies in Israel are doing that, including some research centers of Samsung, for example. And also Trax, and I will go back to Trax by the end of this session. I also want to note that in the academia in Israel, there's a lot of research with computer vision. For example, in this application, it's from a guy from Tel Aviv named Yair Adato. The idea was to change the aspect ratio of the image in a way that nobody can detect it. So this is the original image. And as you can see, and this is the real time of the algorithm, as you can see, you can change the aspect ratio, put it in a different device, or do it, I don't know, if you want to change it, and you cannot tell which one is the original image. You can use the same algorithm to eliminate undesirable feature in the image. Again, it's completely automatically. It's not that somebody go to Photoshop and fix it, and it will be very hard to detect the change. So this is probably the best algorithm if you decided that you need a new boyfriend and you want to change it from the last trip to, I don't know what, Thailand? So what does computers see? So this is what computers see. A bunch of numbers, matrix, numbers between 0 to 255, which represent the color, and this is the input of the computer. From this, we would like to say something like, oh, everybody can see here, this is the two happy girls, probably twins, sitting and enjoying the beach on a windy day. this is the goal of computer vision. And for doing that, you should actually collect a lot of data from the image. You should say that this is a beach, and this is a sea, and this is a wind, and this is a sky, and this is a person, and this is a face, and the face are happy, and the face is similar. So in order to be able to extract so much information from the image, you need to do a lot of complicated stuff. So let's start with the most simple one. And I would like to show you how to do a face detection. And the idea is that you can do it by yourself. It's actually something that we know how to do for, I don't know, maybe 15 years now. And you can all do that. So our goal now is to do a face detection. How are we going to do that? We are going to use an open source library that's called the OpenCV. It's free. It's implemented in C++ or Python. There's a wrapper to almost everything, Ruby, MATLAB, Java, and it's working on almost every platform. So if you want to do it for mobile, it's working for Android and iOS. And they already implemented a bunch stuff of algorithm, reconstruction, 3D understanding, stitching, if you want to do a panorama, many stuff. Good tutorial, take a look. So if you would like to detect a face, or if you would like to detect, to observe something in the image, it's something that we call high-level image. And the idea is to use the machine learning mechanism. What is a machine learning? We are going to have a big collection of data, and we're going to learn from this data the thing that we would like to detect. For example, from this face detection, we have an offline process. We took a bunch of faces. In the offline process, we learn something from this data, and we achieve a classifier. Now, after you do that, the classifier is simply an XML file that you can apply to a new sample. So now I have new image. I never saw this image before. I can use the classifier that I obtained earlier and detect the faces. How we are going to do that? This is a very naive code sample. As you can see, I'm capture the camera. This is the here. I try to talk louder, and after I capture the camera, I grab a frame from it. And now I can try to detect a face in it. How we are going to do that? Simply by take the classifier and detect it. And we would like to, and there is a lot of parameters, almost always in computer vision algorithm. The parameters are really important, and you need to understand them. Why? Because it reflects the reality. For example, here I say that I want the face to be 60 to 60 pixel minimum. If I will put something that is smaller than that, I might have a lot of noise, and it will be harder to detect. So let's compare. Okay, so let's try it. Now the problem is that my mouse is, of course. So these few lines give us this camera, and I hope that I have, okay, and we detect the face. Now it's working really fast. It's something that you can all do. It will work on the cellular. It's very easy, actually. As you can see, there's some noise, but there's always noise and problem in a computer. Oh, here. Now let's say that I want to add to this a smile detection. Let's say that I want to build some application that detects smile and take the picture only if I smile. So for that, I can go to the same framework. I will train a smile detector. Now I apply the smile detector exactly as we did before. Now what I want to say here is that, I'm sorry that you don't see the font, but what I want to say here is that you cannot apply it as is. You need to think a little bit how to connect all this algorithm together. Because if you try to detect the face, the smile now, all over the image, we will end up with a lot of noise, and it will be harder to do. The right way to do that, which is not here, but here, is to say, hey, I know where is the face. I know that smiles comes inside the face. I know the scale of the face. So now I will apply the smile detector only inside the face and only in the right scale. So you know more information and you can use that. Let's try it. And this is the part of the lecture that I'm doing in funny faces. So you can take a look after that. I will put the lecture in the web. If I smile, it's supposed to change the box to red. Is it working? Okay. Yes. So, smile detection. Okay, question until here? Something about the framework of detection? Great. So let me talk a little bit of what we are doing at Trax. So the best way to do that is probably to put the movie.
Technology that will enable you to gather in-store information more conveniently, including information about competition, make it available in the store during the visit or at the head office, and introduce revolutionary ways to get actionable data in real time to drive greater store performance for your brands. For today's industry leaders, defending their market position, customer management, as well as product availability and visibility is crucial for efficient sales. Today, most of the store data comes from either third-party agencies or your sales force, which record the data manually for a sample group of stores. Information is entered into proprietary systems by scrolling through long lists and clicking tiny checkboxes. Accuracy is based on manual count that naturally lacks consistency or reliability. Full reports are available only days ahead for management. With Trax on your smartphone or tablet, you will be able to collect data from all your stores on a daily or weekly basis, gaining full and comprehensive insights in real time. Day-to-day life of your sales rep will change drastically as you simply take a few images of the respective shelves and categories. Trax even tracks your point-of-sale materials or special promotion exhibitions. The images are uploaded immediately onto the cloud servers and are analyzed by Trax's state-of-the-art image recognition system.
So the idea is, sorry. So the idea is to take an image. Somebody took for us the image at the supermarket. There's a lot of SKU. There's a lot of product in that image. And the idea is to detect that this is a Coca-Cola, and this is also a Coca-Cola, and this is also a Coca-Cola, but this is actually not a Coca-Cola. It's a vanilla flavor Coca-Cola, and it's a different product, even though it looks very, very similar. And this is the regular Coca-Cola, but as you can see, this is a different size of Coca-Cola. So our goal is to detect every product in the right scale, in the right size, in the right flavor, in the right everything. And the task is, of course, very challenging. From this detection, we are doing the reports and actually we are collecting the data for our clients. And now why it's so complicated? It's so complicated because here there are many, many different products. Now, the woman here might be recognize that this one is one type of shampoo, and this one is a different type of shampoo. Actually, this one is without a conditioner, but most of the guy here, I guess, will be hard task to do.
Maybe and using shampoo too.
Yes, but you don't know if there is a condition in it or not.
I know.
Rafael Special. And actually, there are here a lot different type. Sorry?
Anyway, we don't have
That's also a problem. that we can solve with computer vision, actually. And the idea is to detect any type of product very specifically. Now, if earlier I told you that you can all go home and detect faces easily, that might be a little bit more tricky because the resolution of the task and the algorithm that you need will be much harder. So one of the things that you need to understand in computer vision, what is an easy task and what is a hard task, and maybe you should talk with somebody with experience for that. So as I said, what is our goal in Trax? The goal is to build a recognition engine that can detect any product in the world. It should be fine-grained recognition. It's not supposed to say this is a face or this is a bottle. It's supposed to say something like this is the special edition for the Olympic game of Coca-Cola sold only in Greece. It should be fast. It should be reliable. And of course, we are talking on a big scale data, so it should be scalable. To summarize, I try to convince you that PHP is cool, but computer vision is even cooler. You can try to play with that. There's a lot of open source library that well documented with tutorial that you can use. Start with OpenCV and maybe PCL. It's free for use. And what we are doing in Trax, which is, as I said, a fine-grained recognition. Thank you. I think that we have time for question.
Let's know how wide base of math do we need to know in order to get started with computer vision?
So this is an excellent question. How much math you need to know if you want to do computer vision algorithm? So it depends what you want to do. If you want to use the existing computer vision, you don't need to know math. You need to read the tutorial. You need to understand the spirit of the thing. You need to build some, some intuition on it, and it will be good enough. If you want to develop a new algorithm, it also depends on which type of algorithm you want to do. Some of the researchers in this area came from very solid background of math, but others are not so much math guy, more than engineering or machine learning. So you can start without a lot of math to conclude. More questions? Okay, thank you very much.